1200 kilogram car freely rolling at a speed of 8.3 meters per second collides with a stationary truck of mass 10,000 kilograms. Now, if as a result of the collision the truck moves with a velocity of 1.4 meters per second, the question wants us to determine the final velocity of the car just after the collision. So here we have a question, right? And the first thing we will do is make a quick sketch of what this question is referring to. So this is our quick sketch, right? So we have our car which is moving with a velocity of 8.3 meters per second, right? And has a mass of 1200 kilograms, just as the question says, and we have a stationary truck of mass 10 kilograms. Now, because this truck is stationary, it means that it is not moving, and therefore its velocity will be 0 meters per second. Now, the question wants us to determine the final velocity of the car just after collision. So, for us to work this question, we'll have to look at conservation of momentum, momentum. Now we know that momentum is the mass times the object's velocity, and the principle of conservation of momentum actually tells us that momentum, let's call momentum P. So momentum before for a system is equal to the momentum after in that system. So we can write then a formula which says that momentum of a system before, so in this case we have two objects in our system. This is let's say this is object A and we have object B. So these are two systems these are two objects in the system. So we can say M1 V1 plus M2 V2, where this is the momentum of system A, this is the momentum of system B before collision. And from our formula we're saying that the momentum, which is the total momentum of the system before, is equal to the total momentum of the system after. So therefore we say that momentum is conserved. So we can write now M1 V1 plus M2 V2. So we're saying that the total momentum before collision is equal to the total momentum after collision. So therefore momentum is conserved. So let's look back at the question now. So we have two objects, a car moving with velocity 8.3 meters per second and has mass 1200 kilograms, and it collides with a stationary truck of mass 10,000 kilograms. So let's fill in some values right now. So let's write mass 1. Let's consider mass 1 to be the mass of the car. So we'll say 1200 kilograms multiplied by our velocity, which is 8.3 meters per second. So we have 8.3 meters per second. That's momentum of the car plus the momentum of the truck. Its mass is 10,000 kilogram multiplied by 0 meters per second, because we're told that it was stationary, right? That is equal to, I'm gonna go down here, so all of that is equal to 1200 kilogram, which is the mass of the car again, times V1, which is the velocity of the car after collision, plus mass of the truck doesn't change, so we still have 10,000 kilograms multiplied by, and the question said that after the collision, the truck moves with a speed of 1.4 meters per second. So we'll say times 1.4 meters per second. Now let's rewrite this below here and then start to evaluate our question. So we're just going to rewrite this section here. So we have 1200 kilograms. Alright, so we can pull out our calculator and start to evaluate. So we'll take 1200 multiplied by 8.3 and we'll get 9,960 kilograms meters per second. If we evaluate this, 10,000 kilogram multiplied by 0 meters per second, we'll get 0. So we say plus 0 is equal to 1200 kilogram times V1 plus, whenever we evaluate this, let's get out our calculator again. So we'll take 10,000 multiply by 1.4 and we get 14,000 kilograms meters per second. Now we want to find the velocity of the car, which is this unknown here. This is the unknown that we're trying to find after collision. So to do that, what we'll do now is simply simplify this. So let me just simplify this. So we'll have 9,960 kilograms meters per second is equal to 1200 kilograms times V1 plus 14,000 kilograms meters per second. Now if you notice, you have kilogram meters per second on this side and you have kilogram meters per second on this side. So what I'll do therefore is take this quantity over here so I can actually subtract both. So I'll have, let me change color here. So I will have 9,960 kilograms meters per second minus 14,000 kilograms meters per second equal 1200 kilograms multiplied by V1. Right? Now, when I subtract these, let me get my calculator. And we're subtracting 9,960. We're subtracting 14,000 from 9,960. So we get minus 4,040. Right? And that is equal to 1200 kilograms times V1. By the way, this is still kilograms meters per second. Now, our objective is to find V1. Right, so on this side we're actually multiplying V1 by 12,000 kilograms. So what I'll do then is divide both sides by 12,000 kilograms. 1200 kilograms. And divide this here by 1200 kilograms. So, taking our calculator again, we have 4,040, negative 4,040 divided by 1200. And that is minus 3.37 minus 3.37 meters per second is equal to V1. 1. So our answer then now is that velocity, so let's say velocity of car after collision is minus 3.37 meters per second. And you might be asking yourself, why is it that we have a negative value? And this is because since momentum is a vector quantity, so it has a magnitude and a direction, it means then that this car is moving in the opposite direction that it was before. So if it was moving eastward, based on our diagram, if it was moving eastward after the collision, it starts to move westward. That is why we have the negative in our answer, because momentum again is a vector, so it has a magnitude and also a direction, and this negative actually represents the direction of the vector momentum. So this was Junior Roberts coming to you with realjuniorroberts.com. If there was anything in this question or in this video that you wish to get further clarification on, please feel free to send me an email. I'll do my best to clear up any misconception for you. If you think this might be helpful to someone, hit the share button, subscribe, and hit the bell notification so you can get further videos when they become available. Thank you for watching.